children, today I am here to teach you chapter 11 in your textbook, that's symmetry. So what is symmetry? Now if I draw a line along this one, what can you say about this side and this side? Left hand side and right hand side? It's coincide. I get the same shape both sides. So something like that is called symmetry. But we are only discussing about 2D figures and polygons, shapes, and see what are symmetrical ones in this lesson. Look at this one, this plane figure. So if I draw a line along this one, AB line, what can I say about these two sides? When I fold this figure along this, I get the same shape there. Overlaps this side to other side. So we call these are bilateral symmetry. Bi means two. So divided this figure into two equal parts. Following plane figure, when folding through AB, we get two identical parts which coincide with each other. This is called a plane with bilateral symmetry. So AB, this line is the axis of symmetry. So remember this word, axis of symmetry and bilateral symmetry. Look at these alphabetical letters, A, D, U, H. What can you say about those? Here, if I draw a line along this, I get two identical parts. So this line is the axis of symmetry. So it has one axis of symmetry. D letter, when you draw a line along this way, we see this side coincide with this one. It's also bilateral symmetry. This also, here this side is equivalent to the other side. You get bilateral symmetry. That's one axis of symmetry. When you take the H letter, if this height is equal to this height, we can draw here as well as here. So two axes of symmetry there. So these letters in the alphabet have symmetry. Some letters have one symmetrical line and some got two symmetrical lines. So H has two symmetrical lines. Equilateral triangle. What is equilateral triangle? Each angle is 60 degrees and all sides are equal. So we'll see how many axes of symmetry are there in this. So I'll take blue color. Okay, so we'll see how many axes of symmetry. I can draw a line here. And this is also okay. I can divide this into two equal parts. And then this way. So I can draw three axes of symmetry. So if you take the whole figure, I can draw the three lines on the same figure like this. This one and this one. When you draw it, what can you see? There's an intersecting point. So we'll take O as the intersecting point of the axis of symmetry. So in equilateral triangle, how many axes of symmetry? You get three axes of symmetry. So three axes of bilateral symmetry, because we are dividing the figure into two equal parts. Square. Square means all sides are equal. So we'll try to draw the line of symmetry. So when you take this figure, I can draw a line along this way. So that's one. Then I can draw another line this way. Then another one here and here. And what about this? You can draw a line along this way or this way as well. So how many axes of symmetry are there? So altogether 4 axes of symmetry. If I draw all these in one, it looks like something like this here and here and here. Here, when you draw all these axes of symmetry, you will notice that it intersects at one point. So altogether 4 axes of bilateral symmetries they are in a square. Rectangle. When you take rectangle, opposite sides are equal. And these all are 90-degree angles. So how many axes of symmetry are there? I can draw a line along here. So it divides into 2 equal parts. Also, I can divide this along this way. So 2 axes of symmetry. If I draw this one on the same figure, I get here and here. So it intersects at one point here. This is the point 4. So how many lines of symmetry are there? Axes of bilateral symmetry? Only 2 in a rectangle. Regular hexagon. Hexagon means 6-sided polygon. Regular means all sides are equal. So what do you think? How many axes of symmetry are there? I can draw a line here. It divides into 2 equal parts. And I can draw a line here as well. Then this way. What about this way? So you get how many axes of symmetry? So we did this, this, and here we did. Now again I can divide this into 2 parts like this. And also if I take this side, I can divide into this way. So here, how many axes of symmetry are there? 1, 2, 3, 4, 5, 6. So in a regular hexagon, there are 6 axes of bilateral symmetry. Isosceles triangle. We'll take isosceles means only 2 sides are equal. How many axes of bilateral symmetry? We can only divide into 2 parts like this. We can't draw a line there because these 2 sides are not equal. So how many axes are there? Only one. So we can say in an isosceles triangle, there is only one axis of symmetry. We can say axis of symmetry because there's only one symmetrical line. Angle with same arm length. So this is an angle. So this length is equal to this length. So we can draw a line here. So this is the axis of bilateral symmetry. This divides into two equal parts. So actually what is that? That's the angle bisector. So there is only one axis of bilateral symmetry in an angle with same arm lengths. This is the angle bisector. Draw the axis of symmetry in the following figures. Look at carefully and try to draw. So if all sides are equal, so we have to assume these all sides are equal, then I can draw a line there. And also here. What else? Can I do this way? Yes. And also I can draw a line along this way. So how many axes of symmetry are there? So we get 4. 1, 2, 3, 4. 4 axes of symmetry. This one I can divide along this way. And here also this way. What else? Can I draw this way? You can't. So only 2 axes of symmetry in that figure. This one I can draw a line like this. We have to assume this side is equal to this side and all these sides are equal. Then this way also possible. I can divide into 2 equal parts. So how many axes of symmetry? 2. This one I can draw a line here, here. What about this way? I can draw this way as well as this way. So altogether 4 axes of symmetry. So I can write 4 there. This one, these two sides are equal. Then we can draw axis of symmetry this way. But we can't draw along this side. So only one axis of symmetry. This one, these two sides are equal. So I can draw a line like this. That's one axis of symmetry. This figure, I can draw a line here. Can I draw here? This way? What do you think this way? Am I getting the same thing? Yes, you can fold it this way as well. So how many axes of symmetry there? You get 2. This one. These two lengths are equal. That means I can draw a line here. I can fold it this way. You get the same shape. What about this way? This way also I get same thing on the other side. So two axes of symmetry in this figure. This shape, if all sides are equal, these sides are equal, I can draw a line here and here. So how many? Two axes of symmetry. In this figure, if all sides are equal, I can draw a line here and here. So only two axes of symmetry in that figure as well. Put correct sign for correct statements and wrong sign for incorrect statements. There are two axes of bilateral symmetry in a parallelogram. What do you think? Parallelogram, only opposite sides are equal. So you can't fold it this way because this side doesn't overlap with the other side. This way also you can't draw. You can't draw here or here. So there are two axes of bilateral symmetry in a parallelogram. That's wrong. No axis of symmetry in a parallelogram. Right angle triangle with equal arms in the angle has one axis of bilateral symmetry. Right angle with two equal arms. These two lengths are equal. So what's the symmetric line? We did that before. That's the angle bisector. So it has one axis of bilateral symmetry. That's correct. There is one axis of bilateral symmetry in a scaling triangle. Scaling means all lengths are not equal. So you can't draw any axis of symmetry. So this is wrong. You don't get any line. There are 5 axes of bilateral symmetry in a regular pentagon. So when you take a pentagon, all sides are equal. So 5 sides are there. So you get 5 axes of symmetry. This way and this way. Altogether 5 axes of symmetry. So that's correct. Now we'll look at rotational symmetry. So far we discussed about the axes of symmetry. What is rotational symmetry? We can take clockwise rotation or anti-clockwise rotation. Anti-clock means counterclockwise is also okay. So what is clockwise rotation means? Rotation is according to the direction of rotation of hands in a clock. So this way we call clockwise and anti-clockwise. So here this way we rotate. That's called clockwise. Anti-clockwise or counterclockwise means we are rotating this way. That's the opposite direction of hands in a clock. What about bicycle wheel? You can rotate either clockwise or anti-clockwise. But when you take ceiling fan, always rotate clockwise. Take this figure and we'll see how many times we are getting the same figure when we rotate. Now take this one. So this is the point is O. And A, B, C, D points are labeled. So this is the first position. Now we'll rotate 90 degrees. So I want to show you with colors. Now I'll take this one is green color. Now when you rotate 90 degrees, what happens? 90 degrees, A comes here. So this whole thing rotates like this, and A, B, C, D, these are the new positions when you rotate 90 degrees clockwise. So this petal comes here. So from the original position, 90 degrees when you rotate, you get this. Now we'll see from here another 90 when we rotate, what happens? What happens now? Earlier here, and then another 90, the petal, green petal comes here. So A position comes here, A, B, C, D. So clockwise, same position is there, but the starting point of A is here now. That's 180 degrees. Now another 90, that means 270 altogether. So what happens? This petal goes here. So now the A position is here. So how many times you got the same thing? Now so far 3. 90, 180, 270. We'll rotate another 90. Then you get the same position as the original one. So in this figure, the petals coincide when it is rotated 90, 180, 270 and 360 again. So we call, there are four order of rotational symmetry. Order of rotational symmetry means how many times you get the same shape when you rotate clockwise or anti-clockwise. So this time we did clockwise, starting from 0. If it's original position, this one is 0, 90 degrees. You got the same shape, 180, 270 and 360. So that means when above figure is rotated about point O. So this is the point O. It is coincide 4 times with the original figure. So there are 4 order of rotation symmetry. The point O is called the center of rotation. So when you take this point, this is the center of rotation. Now we'll take this one. Now 3 petals are like that. So first position, we'll take another color. We'll take this petal. Okay, that's the first position. So when you take this time 120, you get the same shape. So this A petal comes here. So 120. Another 120. So that's 240. What you get? The same petal here. So A position is there. A, B, C comes like that. Then again another 120. That's 360. You get the A petal at the same position as the first one. So when you rotate 120, 240 and 360 in this one, you get the same shape, coincide with the other ones. So that means, what's the order of rotational symmetry in this figure? We get 3. So 3 is the order of rotational symmetry, and we call this point O is the center of rotational symmetry. Now we'll look at an equilateral triangle ABC. So ABC is an equilateral triangle. Rotate clockwise. Find out order of rotational symmetry. So we'll take this one as the first position. First position A, B, C. So this way, so you have to observe the letters clockwise. A, C, B. So when you rotate 120 degrees, so A comes here. So here we are rotating clockwise. So C here, B here. So A, C, B like this. As all sides are equal, you get the same shape again. Then another 120, that's 240 degrees. What happens to A? A, another 120, A comes here. So ACB, so follows the same order ACB. So all sides are equal. Then another 120. A, when you rotate, you get the same position as A, C, B. So same position as the first one. So how many times you get the same thing? We get 1, 2, 3, because we can't count this one. The first position you can't count 1, 2, 3. So order of rotational symmetry is 3. Take this square, rotate clockwise and find out order of rotational symmetry with the label diagram. Now observe this one. If this is first position, so here A is there. Now we have to look at the order. A, B, C, D clockwise. The letter order is A, B, C, D. So when you take 90-degree rotation, you get A here, B, C, D like this. Then another 90, that's 180. So A goes here, A, B, C, D. Then another 90, that's 270 degrees. What happens to A? A goes here, A, B, C, D. So all sides are equal. So 270 also you get the same shape. Again another 90 degrees, that's 360. You get the original shape, A, B, C, D. So that's the order of symmetry in a square. Now what's the order? How many times you get the same thing? 1, 2, 3, 4. So order of rotational symmetry is 4. And when you are rotating, so what is the center of rotation? Center of rotation is the point where you get all the axis of symmetry intersection point. So this is called the center of rotation. So when you rotate the figure from that point, you get all these 4 figures. So this is order of rotational symmetry is 4. Rectangle PQRS is a rectangle. So find out order of rotational symmetry. So this is first position. When you rotate 180 degrees, you get this one upside down. So PQRS, this is clockwise, PQRS this way. Then when you rotate 180 degrees, you get PQRS this way. And then another 180, that means 360 degrees altogether. So PQ comes again to this position. So P comes here, Q there. So P, Q, R, S. So you get the same position. So what's the order of rotational symmetry? You get only 2. So we can say 2. What's the center of rotational symmetry? When you draw the line of symmetry, the intersecting point of line of symmetry we call the center of rotation. So from this, when you rotate, you get these two figures. This is an isosceles triangle ABC. When it is rotated one revolution, it coincides with the first position. So that means if this is first position, you need to again rotate around one revolution. That means 360 degrees. You get the same shape. So we say order of rotation symmetry is 1. When you get order of symmetry is equal to 1, we say there is no rotational symmetry in this figure, because every figure, when you rotate 360, you get minimum 1 rotational symmetry. But for those figures, we say no rotational symmetry because it's 1. So if it's more than 1, we say those figures have rotational symmetry. Rotate this figure 360 clockwise and find out the order of rotational symmetry with labeled figure. Okay, so here this line AB, if this is first position, and when you rotate this angle, it's not mentioned the value. If you rotate this angle, this line goes here. A, C, B, D. So CD line goes there, AB here. Then again, another angle like this. So here it comes here, and when you rotate again, here you get the same position here. So here this A and B comes here, A, C, B, D. So this is when you rotate 360 degrees. Again you get the same position. So how many times you are getting the same thing? Only 2. So order of rotational symmetry in this figure is 2. Look at this one. So rotate this figure 360 degrees clockwise and find out the order of rotational symmetry with labeled figures. Okay, so this is first position. So these 3 lengths are equal. So we can rotate 120 degrees to get this one. So what happens to this A position? A comes here. So think about, if you are rotating clockwise, ACB is the order. So ACB. So that's the position of ABC. So with 120 degrees. Another 120, that means 240 degrees, what happens? A comes here. So ACB. And another 120, that's altogether 360 degrees. Again you get the same position, ACB, ACB. So that's how you get the rotational symmetry. What's the order? 1, 2, 3. 3 times you are getting the same figure. So the order of rotational symmetry is 3. This one. Now this is the first position. Now we'll do 90 degrees. What happens? This part comes here. So here AB. I'll put C here. So C goes there. Now look at the order. A, B, C, D clockwise. So here C, D, A, B. So that's the 90-degree rotation. Now again rotate this one 90 degrees. You get the petal here. So what's the position now? C is here. So C, D, A, B. C, D, A, B clockwise. You get the same order. This is 180 degrees. Another 90. Another 90. That means 270 degrees. What happens to this petal? When you rotate, it goes like this. And what are the letters? C is here, C, D, A, B. And then finally, when you rotate another 90 degrees, that's 360 degrees, you get this one, petal this way, and C comes here, D, A, B. That's the first position again. So what's the order of rotational symmetry here? 1, 2, 3, 4. Or order of rotational symmetry is 4. Complete the table. Equilateral triangle. Number of equal sides, we know 3 equal sides are there, and we found out order of rotational symmetry is 3. Square, 4 sides are equal, order of rotational symmetry is 4. Regular pentagon, 5-sided figure, all sides are equal, you got 5. Order of rotational symmetry, 5 times you get the same figure. Regular hexagon, 6-sided figure, all sides are equal, and you get order of rotational symmetry 6. Look at this table. What you observe? In regular polygon, number of equal sides is the same as the order of rotational symmetry. Only for regular figures. Write down order of rotational symmetry in the following figures. Now we have to assume that if all these lengths are equal, this is like equilateral triangle. Then you can say you get this length here, this length here. So 3 times you are getting the same figure. So order of rotational symmetry is 3. This is a parallelogram. Parallelogram 180. You get the same thing again, 360. So order is 2. This one 4 and 4. This is a square. So what's the order of rotational symmetry in a square? 4. Equal sides is equal to the order of rotational symmetry. This is if all sides are equal, you get 1, 2, 3, 4, 5, 6 points. This is like a hexagon. So 6 is the rotational symmetry. So 1, again 2, 3, like that you can rotate and get 6 order of rotational symmetry. This one, when you rotate 180, this goes down and you get this one up. So that means 180 and again 360. So the order is 2. this one. So you get 90 degrees, 180, 270 and again 364 is the order of rotational symmetry. This one, this part, here 1, 2, 3, 4. So 4 is the order of rotational symmetry here, and this is all sides are equal here. So here you get 1, 2, 3. 3 places you get the same shape. So order of symmetry is 3. We'll look at the review exercise. Copy the following plane figures in your exercise book and draw the axis of symmetry of each figure. So look at this one. So you need to draw the axis of symmetry. Okay, so here look at this diagram. I can divide this into 2 equal parts. Can I draw another line? I can't draw. So one axis of symmetry. So it says copy the following plane figures in your exercise book and draw the axis of symmetry. So only one. What about this one? You can draw here. You can divide into 2 equal parts. This one I can draw along this. Can I draw here? No. This side is not equal to this side. What about this one? This is a rhombus. Rhombus, these sides are equal. So you can draw the axis of symmetry this way. Because opposite angles are equal, so when you take this way, this triangle overlaps with this triangle. Can we draw the other way around? Yes, this way also, okay, possible. So here, if we draw another line like this, that's also possible. This triangle is equivalent to this triangle. So 2 axes of symmetry. Select the figures that are bilaterally symmetrical from the following figures and write down their numbers. Bilateral means only one axis of symmetry and divide into 2 equal parts. So this is a parallelogram. These sides are not equal. So do we have an axis of symmetry? We don't have an axis of symmetry. This is isosceles triangle. So we can draw a line here. So select the figure that is bilateral symmetry means we can select this figure. What about this one? This side is equal to this side. So if we take this way, it's not overlap. This is rotational symmetry is there but not bilateral symmetry. What about this one? Can we divide here? If we divide this into this way, this is equal. So this side is equal. So this is, we can mark this also as bilateral symmetry. The dotted line shown in the figure divides the given rectangle into 2 equal parts. Samit says that the dotted line represents an axis of symmetry of the rectangle. Explain why his statement is not true. So in a rectangle, opposite sides are equal. This side is equal to this side. So what happens? This is 90. We know that. But when you are trying to fold along this line of symmetry, this length is not equal to this one. So it doesn't overlap with the other. So you can write only pair of opposite sides are equal adjacent sides are not equal. That's why we can't fold along this line. Adjacent sides are not equal in rectangle. Fourth question. Copy the given parallelogram onto a tracing paper and cut it out. Can the figure that was cut out be folded along a line so that the two parts on either side coincide? Accordingly, show that a parallelogram need not have bilateral symmetry. So we'll take the figure. So this is a parallelogram. So in a parallelogram, only opposite sides are equal. So this side is not equal. So when you fold along this line, what happens? As this length is not equal to this length, it doesn't overlap with this one. So it's not symmetric. Now if you take this side, what happens? This length is not equal to this length, so it doesn't overlap. And if we take here, this side also doesn't overlap. So here in a parallelogram, we don't get symmetrical lines. So that means doesn't have bilateral symmetry. So you can write adjacent sides don't overlap, don't coincide. We can use the word coincide. Each other. So no symmetrical lines. You can say axis, no symmetrical axis. So we don't get bilateral. We don't get bilateral symmetry. Here we'll revise what is rotational symmetry. When you rotate from a point, we say center of point, center of rotation. If we get the same figure again, we call that's rotational symmetry. How many times you are getting rotational symmetric figures? That means the order of rotational symmetry. So here we did equilateral triangle. What's the order of rotational symmetry? Order is 3, and we got 3 symmetrical lines. And what about rectangle? We get 2 axes of symmetry. And what about rotational symmetry? When you rotate 180, you get the same shape. Again, 360. So order is 2 there. So likewise, what is rotational symmetry? When a plane figure is rotated about a point on it through one complete rotation in the plane of the figure, it coincides with the original position at least once. So all figures we have rotational symmetry 1. Order is 1, because when you rotate 360 degrees, definitely you are getting the same shape. There are some figures which, when rotated about a point on it through one complete rotation, coincide several times. Equilateral triangle, isosceles triangle, how many times? Just one. And square, you get 4 times. The number of times a figure coincides with the original position varies depending on the point about which it is rotated. That's called the center of rotation. So we'll see what are the figures we did. We did these figures: equilateral triangle, number of axes of symmetry, 3. So can you remember? Equilateral triangle, number of axes of symmetry, 3. And order is also 3. So rotational symmetry, yes or no? Yes. Parallelogram, there's no axis of symmetry, but order of rotational symmetry is 2. And this is, yes, rotational symmetry is there. If this is more than 1, we say there's a rotational symmetry. Rhombus, you get 2. Rhombus means all sides are equal. So you get this way and this way. 2 axis of symmetry, and order is also, when you rotate 180 and 360, you get the same shape. Rectangle also similar. Square, 4, because all sides are equal and all angles equal to 90 degrees. Regular pentagon, regular means all sides are equal. So 5 times you can get the same shape. So order of rotational symmetry is 5. And the hexagon means 6-sided figure. You get 6. Order is 6. Octagon means 8 sides. Equal 8 sides. You get order 8. If a geometrical plane figure which has rotational symmetry is also bilaterally symmetrical, then its order of rotational symmetry is equal to the number of axes of bilateral symmetry. Here these ones: rhombus, rectangle, square, pentagon, hexagon and octagon, you get the same values. A figure which is not bilaterally symmetrical can have rotational symmetry, like parallelogram. The center of rotational symmetry of a bilateral symmetrical plane figure which has rotational symmetry is the point of intersection of its axes of bilateral symmetry. So these points, these are the center of the rotational symmetry. The order of rotational symmetry of a figure that has rotational symmetry is greater than 1. If it's 1, we don't say it has rotational symmetry. So we'll see how we can do the exercises. Exercise 11.1. Draw the isosceles triangle ABC in your exercise book as in the figure and draw its axis of symmetry. So you get only one axis of symmetry. So how we draw? We get this line. So that's the axis of symmetry. We'll draw it. This is axis of symmetry. Copy the triangle ABC onto a plastic paper and find out whether an isosceles triangle has rotational symmetry. Does every plane figure which is bilaterally symmetrical have rotational symmetry? What can you say about the rotational symmetry there? If it's isosceles, only 2 sides are equal. So if you are starting from this center, how many times you can rotate to get the same shape? Only when it is 360, you get the same shape. So this is not, no rotational symmetry is there. but we know that it has symmetrical line. So does every plane figure which is bilaterally symmetrical have rotational symmetry? No. Example is isosceles triangle. So here we get axis of symmetry but doesn't have rotational symmetry. Draw a plane figure which has two or more axes of symmetry. Find out whether the figure you have drawn has rotational symmetry. If it has rotational symmetry, mark the center of rotation as P and write down the order of rotational symmetry of the figure. You can draw any figure that you like. Equilateral triangle, square, rectangle, any shape, but which has two or more axes of symmetry. Two or more. So you can take isosceles triangle, not isosceles, equilateral triangle. So how many sides are equal here? We know equilateral triangle has how many axes of symmetry? You get 3 axes of symmetry. So I didn't draw it properly, but when you draw it properly, you get 3 axes of symmetry. And when you rotate 60, so here this is 120, you get same shape. Then again 120, again another 120, 240, you get the same shape, again 360. So 3 times you are getting the same shape when you rotate along this point. We'll say O. So this is called the center of rotation. So we have to write that's P. P is this point, and how many rotational symmetry is there? 3. So we call order of rotational symmetry is 3. Then if it has rotational symmetry, mark the center of rotation as P and write down the order. So that's 3 for the equilateral triangle. Write down the following statements in your exercise book and mark the true statements with correct symbol and the false statements with wrong symbol. Every bilateral symmetrical plane figure has rotational symmetry. What do you think? Take isosceles triangle. Bilateral symmetry is there, but there's no rotational symmetry. So we can't say every bilateral symmetry plane figure has rotational symmetry. That's wrong. Every plane figure which has rotational symmetry is also bilaterally symmetrical. It's correct because when you take equilateral triangle or regular pentagon, regular hexagon, when there's bilateral symmetries there, it has rotational symmetry as well. When it comes to parallelogram, no axis of symmetry, order of rotational symmetry 2. So what can you say about this statement then? Every plane figure which has rotational symmetry is also bilaterally symmetrical. That's also wrong when you take parallelogram. If a bilaterally symmetrical plane figure has rotational symmetry, then the number of axes of symmetry is equal to its order of rotational symmetry. What do you think? Is it always equal? If a bilateral symmetry plane figure has rotational symmetry, then the number of axes of symmetry is equal to its order of rotational symmetry. All regular figures, we found that all are equal. And this one, parallelogram, there's no axis of symmetry, but order of rotational symmetry is 2. All the other figures, you get the same number. So what can you say about that? This statement? If a bilateral symmetry plane figure has rotational symmetry, then the number of axes of symmetry is equal to its order of rotational symmetry. We can say that's correct. Fourth one, the point of intersection of the axis of symmetry of a bilateral symmetrical plane figure which has more than one axis of symmetry is its center of rotational symmetry. So that's true, because when you take equilateral triangle, so when you draw the axis of symmetry, it intersects at a point, and when you rotate from that point, you get the same figure 3 times. So this is called the center of the rotational symmetry. So that's correct. A scale-in triangle. So what's scale-in? All 3 sides are not equal, does not have rotational symmetry, and is also not bilateral symmetrical. That's true, because scale-in means different 3 sides. So we can't rotate and get the same figure. Only at 360 you get the same figure. So that means there's no rotational symmetry, as well as we can't draw any axis of symmetry. So that's true for scale-in triangle. So we covered all theory related to symmetry, bilateral symmetry and rotational symmetry. When a plane figure is rotated about a special point in it through an angle of 360, if it coincides with the original position before completing a full rotation, that means 360, then it is said to have rotational symmetry. The center of rotational symmetry of a bilateral symmetrical plane figure which has rotational symmetry is the point of intersection of its axis of bilateral symmetry. The order of rotational symmetry of a figure that has rotational symmetry is greater than 1. When we have only one rotational symmetry, we don't say there's rotational symmetry in that figure. When a plane figure is rotated about its center of rotation, the number of times it coincides with the original position during a complete rotation is called its order of rotational symmetry. So remember all these terms: order of rotational symmetry, center of rotational symmetry, bilateral symmetry, and axis of symmetry.